Hello students, we are studying Internet Protocol Security. In previous videos, we have seen introduction to IPsec as well as the two different modes in which IPsec is working, that is transport mode and tunnel mode. Now here in this video, we'll be starting with the security protocols which are provided by IPsec. And in this video, we'll study about authentication header protocol. So there are two security protocols provided by IPsec are the authentication header protocol and the encapsulation security payload protocol. So these protocols are basically used to provide the authentication and encryption or authentication or encryption. So means both of them are providing authentication, but not necessarily that they are providing encryption also for the packet at the IP level, that is at the network level. So let us start with authentication header protocol. The authentication header protocol is designed to authenticate the source host and to ensure the integrity of the payload which is carried in the IP packet. The protocol uses the hash function and symmetric key to create a message digest. The digest is inserted in the authentication header. So this authentication header protocol is providing you data integrity, data origin authentication, anti-replay protection, and protects the IP header, but it is not providing you confidentiality. So these are the services provided by authentication header protocol. So let us see how it is working. So this authentication header protocol, it uses the hash function and a symmetric key. It creates the message digest and then the digest is inserted in the authentication header. And the authentication header is then placed in the appropriate location based on which mode, transport mode or tunnel mode is used. So see here we have the authenticated part where we have the IP header and here we have the authentication header. And then this is the payload which is coming from the transport layer. That is upper layer payload. So this is the authentication header format of authentication header protocol. It is having these different fields. We are going to study it. And it is providing a data origin authentication, integrity, anti-replay protection. But remember here that it is not providing you confidentiality. That is, encryption service is not provided here. So let us understand these fields of authentication header in more detail. So when the IP datagram carries the authentication header, the original value in the protocol field of IP header is replaced by the value 51. And the field in authentication header, next header, holds the original value of protocol field. So for that, you first remember what is IP format of IP header. So see here, this is your IP header format. Now here in this IP header format, you have the protocol field. See this. Here we have a protocol field. So this, whatever value is here in the protocol field, the original value in the protocol field of IP header, whatever value it is carrying, it is to be replaced by the value 51. So when this protocol field carries the value 51, it indicates that the authentication header protocol is used. And then this original value of protocol field. So this value is then inserted here in the IP header, the next header field. So this next header field, first field will then carry the original value of protocol field of IP header. So that value is basically giving you the information that which upper layer payload it is carrying, whether it is carrying TCP, UDP or ICMP. So that value would be copied here and then the protocol field is replaced with the value 51, which indicates that it is carrying the IP header. Now the next field here is the payload length. Okay, before understanding these fields, first I will explain you that how this authentication header is inserted. So first, the authentication header is added to the payload with this authentication data field. The last value here in this authentication header format is the authentication data, which is calling the message digest. First, that value of that field is to be set to 0. Then we have to add some padding. Why this padding is required? Because whatever hashing algorithm you are using, the MD5, SHA1, okay, so to make the entire message multiple of that 512, we have to add some padding bits. So padding may be added here to make the total length even for a particular hashing algorithm. Then we have to apply hashing based on the total packet. However, here only those field of IP header is to be considered while hashing which do not change during transmission and included in calculation of message digest. So what are fields in the IP header change during transmission? So here you can see in the IP header, we have the time to live field. So this time to live field is the one which can change during transmission. At every hop, the TTL value will be reduced by 1. So this changing value will not be considered while calculating the message digest. Then the authentication data is inserted in the authentication header. And then the IP header is added after changing the value of protocol field to 51. As I told you that the protocol field of IP header is to be changed to 51 and the original value of this protocol field is to be inserted here in the next header. And this way we can insert the authentication header. Okay. Now let us understand these different fields of authentication header. So first is a next header field. So this next header field is the of length 8 bit. So this next header is the 8 bit field. It defines the type of payload which is carried by IP datagram. As we have seen that the original value carried by protocol field of IP header is copied here. So it will give you the information that which upper layer payload is carried by that particular packet, whether it is TCP, UDP, ICMP or OSPF payload. And it has the same function as the protocol field in the IP header before encapsulation. So here the process copies the value of protocol field in the IP datagram to this field next header, and the value of the protocol field in the new IP datagram is now set to 51, which will show that the packet is carrying authentication header. Then the next field is the payload length. So so actually this payload length field, the name of the field is actually misleading. It is 8-bit field and it does not define the length of the payload, but it defines the length of authentication header in 4-byte multiple, but it does not include the first 8 bytes. Then next we have the security parameter index. So this security parameter index is a 32-bit security parameter index field which plays the role of virtual circuit identifier, and it is same for all the packets which are sent during the connection, which is called security association. So we are going to study this concept of security parameter index and security association in the further slides in the same unit. Okay, so here you just have to remember that this security parameter index is a 32-bit field, which is a virtual circuit identifier, and this SPI is same for all the packets which are exchanged during this security association. Then we have a sequence number. Again, this is a 32-bit field sequence number which provides the ordering information for the sequence of datagrams. To arrange the datagrams or the packets at the receiver side in a sequence, we can use this sequence number. Here the sequence number prevents the playback. And here we have to remember that the sequence number is not repeated even if the packet is retransmitted. new sequence number is to be used always. And the sequence number does not wrap around after it reaches 2 raised to 32, because see, the size of this field is 32-bit. So it can only give the sequence number up to 2 raised to 32. And when it reaches up to 2 raised to 32, we should not restart it, but a new connection has to be established. Then the next one is the authentication data field. The authentication data field is the result of applying the hash function to the entire IP datagram except the field that are changing during the transmission. That is your time to live field. Okay. So this is all about authentication header. Here we have to remember that the authentication header protocols the data origin authentication and data integrity, but it is not providing confidentiality as it is not using any kind of encryption algorithm.